what we have here are our wall of probing products which have been redesigned specifically for the robotic application. A lot of these, in terms of the actual mechanisms internally, are based on our existing, tried and tested, well understood, so we're confident that they are reliable and robust in practice. What we have are a range of radio, optical, wireless probes, and then wired probes designed for different sizes of robots. So a smaller one designed for maybe smaller SCARA, smaller base 6-axis arms, and then largest ones which are designed for the full range. PK3 range is designed to be modular. So this stays on the robot itself. It's covered and capped, so if it's then working in a dirty environment, it's completely protected, IP protected. And then when the probe is needed, the robot can drive over to it, we put the probe back on, and then it can conduct its measurement or its datum in operations, and then be dropped off again in a safe location. The other main change for this probe type is typically you've got a little bit of overtravel, but robots move quite quickly and can sometimes be in areas you weren't expecting them to be. So it also has additional overtravel within that as well. So if it ever collides, the whole mechanism is protected. So making it more robust and making it modular so that it can easily come on and off. And then over here, we have our tool setting range. So once again, very similar technologies, different styli configurations. The disc stylus that you see there is to be used in conjunction with spindle calibration, so being able to find 5 degrees of freedom on a spindle. And then below that, RPUs, which are basically our probing controllers, and they are used in conjunction with the probes. They're plugged directly into the controllers of the robots, have all the macros which are created by our technical team, which means that the implementation is very straightforward. Our supporting software allows you to import a CAD model, say exactly what you want to find, and it automatically generates a pseudo template program, and then it's very quick for an integrator to install it with our set program. So we handle all the metrology, all the measurement side of things, and it frees up the integrators to get on with what they're best at doing in actually setting up the cell. So yeah, that is our probing range. It's just gone through there is a TCP reorientation. So as an example on the screen, you can see before a calibration had been applied, how the TCP was performed, and then after the calibration has been applied, how that tightens it up so that the error is drastically improved, bringing it to much better performance levels. Those are our ball bar-based technologies. Then to complement those are our probing-based technologies. So Renishaw have been making probes for many, many decades. We've taken those approaches and technologies and applied them directly to robotics. So by using a tactile probe on the robot and tool setters in front of the robot, we're able to understand what is happening on the robot and the tool itself, and then what's happening in front of the robot. So you can automatically find parts, find tools, update them relative to each other so that you're then able to automate automation a lot more smoothly, get these cells up and running faster. And if anything does go wrong in the future and a crash occurs, you can recover it back to a known working state without the need of external expertise. So providing more accuracy and giving peace of mind to all users as well. And that really in a nutshell is what we're showing and today here.